Recording. Okay, hi. Welcome everybody to the kickoff for the Seattle Quantum Computing Meetup's Qiskit Fall Festival 2024. And we have been chosen as an official sponsor for this event by IBM. There are 50 universities and maybe some other types of groups who were selected as a sponsored event. And then there were 50 who were selected as an extension event. And we were one of those 50 for the extension events. The UW was also selected, and they are they have their own website and are hosting an event. And I believe their events are tomorrow and Friday evening, and their target is students, as I understand. I'm not sure if it's broader. I might go tomorrow to check it out. It was a competitive application process, so it's exciting that that we were selected. Okay, so I'll show you here actually. So this Qiskit Fall Fest, IBM's idea with this event is to start introducing people to Qiskit, and then it's more on the beginner level than some of the other events that they offer. They offer in the spring a spring challenge, which consists of a bunch of Jupyter notebooks featuring aspects of Qiskit. And I believe that lasts for a week or two. So if you enjoy this, get your feet wet, then that's something to look forward to next year to participate in. And in the summer, they host a summer school, which they call the Qiskit Global Summer School. And for that, they again have Qiskit notebooks that you can work on, individual coding challenges. But they also have a lot of lectures, presentations by IBM researchers and others on a variety of content. And it's really a solid, nice event. So and if you can't, that requires registering ahead of time. And, if you can't make it for that, then they record everything. And after the event is over, you can go to the Qiskit channel on YouTube and check it all out afterwards as well, if you don't want to commit to the summer school itself. So what I'm doing for this event is hosting it on DoraHacks. And it's not officially a hackathon that I'm holding, but it consists of, let's see, can you see this screen well enough, or should I make it any bigger? Let's see here. I don't know if that helps a little bit. So for this, I'll go through the page itself here. The theme for the Qiskit Fall Fest 24 is the world of quantum computers. And I have a to-do list that you can come back to, but I'll move ahead to the schedule. And one thing that you can do to participate in this event is to join the Discord. I have a link here, and users can engage with one another on the challenges there. And if you're interested in forming a team, you can go there and put in a request and find team members. Yesterday, IBM's date was October 1st was the official start date for IBM for the beginning of the Fall Fest. And today I'm hosting our Zoom kickoff, and I posted Qiskit Challenge Notebooks that you can start working on. Next week, we have a lecture by Peter Shore at the University of Washington, and a group of students in the ACAT program at the University of Washington are hosting that, and they invited Peter Shore, and he agreed to come. And so that should be really wonderful. We're going to hold a little bit of a meetup session about 30 minutes before the lecture, and possibly after the lecture if folks want to chat with one another at the event. It's in Kane Hall at the University of Washington, and you should register with the University of Washington's link if you want to go to that lecture. Okay, later in the month, I'm going to release what I'm calling scavenger hunts and business challenges. And the purpose of, let's see, so today I released Qiskit Challenge Notebooks, and the purpose of those is to help you learn the features of Qiskit, and you can be brand new to Qiskit and get started with this. For the scavenger hunts that is not coding focused, but more of a research topic-based focus on quantum computing. So ways that you can learn it without having to write code to try to program a quantum computer. For the business challenges, the idea there is to identify a use case that a quantum computer could be used for and then develop that out. And those aspects I'm still working on and plan to post those around October 17th or somewhere in that window, starting October 17th. Let's see. I'll have another Zoom check-in at that time. On November 7th, we have some space reserved at the Microsoft Reactor in Redmond for an in-person event, and the exact agenda I will announce later. November 25th, the event will end and all materials will be due at that time. Let's see. So we don't have any cash prizes, but what we do have to offer are certificates that IBM have provided. We have two types. One is a certificate of participation, and that will be awarded to folks who create a buildle, and that's a term that DoraHacks uses. You can see a tab up here called Submission Guide, and that guides you through how to create a buildle. And it's pretty simple. One approach is to create a GitHub repository containing your files, and then just link that. And let's see, I'm going to click away from the Details tab to the Buildles tab. You can see here for anyone who submitted buildles, they'll show up on this page. Let's see. So the level of participation is going to be a little bit lower. You can get a certificate. It'll be a little bit lower than for a winning achievement. And winning achievement is for people who've completed all 3 graded notebooks and have submitted a job to real IBM quantum hardware. So IBM provides for free 10 minutes of QPU as opposed to CPU, QPU time per month. And with these notebooks that have been provided, there are a couple of cells in there where you can submit your job to real IBM quantum hardware, and you get a job ID back. And that's something that could be fun for you to try. So likely your job will go into a queue, and it'll take a while for it to run. But later you can go back and look at the results. So for this, you will want to get an account on the IBM Quantum platform, which is free and does not require a credit card to set it up. Also, winning achievements can be obtained by completing a scavenger hunt that I'll post later, or a business challenge in full, and by submitting a buildle that contains evidence of the work that you did for that. People can work alone or work together in teams. And as I mentioned earlier, if you want to you can find your own teammates, or if you want to go to the Discord, you can try to find team members through there. Okay, so what I will do is go straight to the Qiskit challenges, because I think that all of you might enjoy learning the Qiskit through these as a starting point. Since we are going through all the way through to November 25th, you can try these Qiskit challenges first. And then after that, you can take a look at the scavenger hunts or the business challenges if you want. You can do as much as you like. For these beginner challenges, IBM has assigned them a difficulty score of 1 out of 5. For the intermediate challenges, they have notebooks, Jupyter notebooks, that they rate as 3 out of 5 difficulty score. For each notebook, at the top of the notebook, they estimate how much time it would take to go through it. They kind of put an estimate there on the low end because, of course, you can spend a lot more time learning more about the topics, and the more time you spend, the more useful it'll be in terms of the learning of those topics. For the last challenge, the advanced challenge, that is, we can look at that notebook to see what the difficulty score they rated it as, but I put it under the advanced challenge because the topic itself, the CHSH inequality, I think can be considered advanced topic in itself. But as far as the notebook goes, IBM has supplied all of the code and you just have to run the cells. So it's not challenging in terms of writing code because they provided everything. You can just run it and study the steps as you go along, and then just use it as an opportunity to learn more about the topic. So the way you can run these notebooks, let's see, if you click on one, what happens is, what it just happened there for me is that it downloaded it to my PC. And so once you have it downloaded, what you can do is, the simplest way to get started would be to upload it into Google Colab. Another alternative is, if you're familiar with Python and Python environments, you can create your own Conda environment and run this notebook locally on your own machine. Let's see. So what I thought I would do here is, let's see, I guess, take a look. So if you want to use Google Colab, I don't have a lot of experience with Google Colab, but when I tried it the other day, it went really fast and it was not. So I just did a Google search for Google Colab. Oops. Oh, welcome to Colab. All right. So file. So I just did a Google search for Google Colab, and then I clicked on it and it says welcome to Colab. I'm going to going under file, and it says upload notebook, and browse or drag a file here. Let's see, I think I can look at my downloads. Created notebook number 1. So 3 of these notebooks that IBM provides are graded, so you can run the cells and it'll tell you if your answer is correct or not. So here's looking at the first graded notebook, Welcome and Hello World. They estimate 30 minutes to get through this notebook. I will scroll down. So I'm in Google Colab, and I scroll down, and they give all the links for extra information about getting started. But what you can do is just run each of these cells, and when you run the cells, let's see. I'm going to run the first one. So I just clicked on that arrow, and so it's running it right now to install the needed libraries. What I was going to do here is, if you're not familiar at all with Qiskit, I wanted to show you that in Google, I did a search saying, is Qiskit a programming language? And it kind of depends, just like what you want to make consider as a definition for a programming language. Google AI says, no, Qiskit is an open source software development kit that allows users to program quantum computers using Python. As for programming language, it says it uses Python. It also has incorporated some Rust in order to improve performance in some areas. if I scroll down a little bit, IonQ has written about it, and it says IBM's Qiskit was one of the first frameworks for programming quantum computers. It provides robust tools for writing quantum programs in Python, as well as a variety of additional packages for working with quantum hardware, running common algorithms, and more. And again, there's a little information from Wikipedia about Qiskit, indicating that the primary version of Qiskit uses the Python programming language. Versions for Swift and JavaScript were initially explored, though, blah, blah, blah. So I just wanted to show you that is for a better understanding of what Qiskit is if you haven't seen it before. Okay, let's see. So I ran this cell in the Colab, the first cell, and it says, it looks like everything that installed Qiskit, as you would, if you've used Python before, as you have experienced doing a pip install previously for a package, you see that looks like everything's installed okay. And it says Qiskit should now be installed and ready to go. And then here we go is you run another cell and it's creating this, you can see here it's creating a quantum circuit, QC equals quantum circuit, adding a gate to it, which is a NOT gate. And then it can use QC draw with matplotlib and makes a drawing of the circuit itself. So this is a 1 qubit circuit. And then you just continue on in this way. There's more installs here of packages, and one of the packages, the last one being installed here, is the grader, as I mentioned. And so I won't run every cell in this notebook, but just so that you can see that it's pretty easy to get started. Okay, so that looked like it was successful. And then let's check your installs and versions to make sure everything is what it should be. Qiskit version 1.2.2 is what we have, so that's good. Okay, check other dependencies. Okay. Grader should be 0, 19, 0. Ours is 0, 20, 0.20.1. So that looks good. Okay, so the API token, they talk about it here. I believe that's really only, so you can create an account on the IBM Quantum platform, which is this purple here. And you can see over in the right-hand corner, there's a window for API token. And I believe the API token is probably only going to be required when you submit a job to actual quantum hardware. I'm going to skip this cell for the token. It was working on my laptop without doing it. So unless I already had something set up. Okay, so I've just been clicking on the arrow to run these cells, and now I'm running this cell. Oh, insert argument. Okay, so I see. So this is the first graded cell, and I'm getting a type check error. Argument answer int is not an instance of string. And the reason that I'm getting an error for this one is because this cell here actually requires a little bit of work. And this is the first point. This is not really anything special to quantum computing, but just to get you used to writing writing code in the Python Qiskit to do this. And so I just changed the answer to be a string rather than an int, and I ran the grader again, and it says that I've successfully figured out how to use the grader for these notebooks. So, okay, so I just wanted to give you an idea there that getting started with the Google Colab can be pretty quick. And we just downloaded the file, and then we opened up Google Colab and uploaded the notebook to Colab, and then just started running the cells to install the needed libraries, Python libraries, and then run the cells. And then this part here, this next part is generate a two qubit Bell state using Qiskit patterns. This part is actually, starting for the interesting educational aspects about quantum computing with the Bell state. The Bell state is an example of an entangled state. So with this getting started right away, you'll be entangling qubits. And so far, let's see what we did there. Okay, what we did there was just Python, which was a variable assigned to a string. But here, what we do in this next cell, what we're doing is we're creating a quantum circuit, adding gates to it. You see QC equals quantum circuit. The 2 there represents 2 qubits. And then we're adding a Hadamard gate and a C0 gate, and the 0 represents the qubit that we had identified with number 0. And this next one, the CX, is a controlled NOT gate, and the control is on the 0th qubit, and the 1 is the gate that the NOT is going to be applied, or the qubit that the NOT gate is going to be applied to. And then we're going to draw the circuit. And in this case, by applying these 2 types of gates, what we're actually doing, we have 2 qubits in this circuit, 0 and 1, and the combination of these 2 gates is doing an entangling operation on those 2 qubits. So that's kind of neat right off the bat. I will run it because we didn't actually have to. I'm not giving any answers away here because I didn't have to write any code there. You just run it and it draws it. You can see it. And so then the exercise 2, this is where you start writing some code. And so anyway, they step you through these what they're calling Qiskit patterns. Just some easy steps. All this is kind of on the basic level to just let you get a feel for what it is and kind of get a feeling of success, I guess, just getting started there. And so there's not a lot left in this notebook for you to do. Okay, so and then the second notebook. Oh, let's see, open notebook. After, you can do them in any order that you want. I'm back on the DoraHacks page looking at beginner challenges, open notebook A, and this one it's called open because it doesn't have a grader built into it. And so I think that it has a cell where you can actually submit a job to real quantum hardware. And then the intermediate challenges, they're just this one creates for the notebook 2, you create a W state, which is an entangled state between 3 qubits. In that first notebook, what we did was we entangled 2 qubits. In notebook 2, we'll entangle 3 qubits. And in that case, it's not called a Bell state, but it's called a W state. And there's also part 2 of that notebook builds up a VQE algorithm, and you can read about that. And this notebook, I believe IBM estimates that it will take 75 minutes for you to go through. But one of the co-creators of that notebook, he suggested that it would be a good idea to spend about 4 hours reading about the VQE algorithm. So that's just an example of how, there's a certain amount of time you can spend just going through the notebook, but of course there's just a lot more time that you can spend studying the topic that you just worked through in the notebook. And then the third graded notebook explores the Qiskit transpiler, and what that does, let me see on my, oh yeah, let me see if I can upload that notebook. Upload, oh, drag a file here or browse. Let me see. Created notebook number 3. This again in Google Colab. So I'll just, before I go start looking at this one, what I'll say is that for the spring challenge and the summer school, I participated in those this past year, and I created a Conda environment because I had experience. I didn't have any experience with Google Colab before, but I did have experience creating Conda environments in Python. And so in these cells where it asks you to install these libraries, I just created a Conda environment and I put these installed these libraries into that. Then I activated my Conda environment, and then I started up Jupyter Notebooks in the directory where I had the Jupyter Notebook, and then I worked on the Jupyter Notebook from there. So you can just do whatever you're most comfortable with. Um, some sometimes people use QBraid, the QBraid platform, also for working with these environments. But I'm keeping it. I'm not introducing that here in order to just keep it on the kind of simpler side. Yeah, so let's see the transpiler. So what happens with quantum computing is, it's like, what is the transpiler? This is a very interesting part to learn. And what happens is, you write your code like this. The circuit here, you have 2 qubits, and you put in a Hadamard gate, you put in a C0 gate. And these are 2 C0 gates. One has a control on the 0th qubit, and the next one has a control on the first qubit, with with the qubit that it acts on as being the other one, where the control isn't. And that's how you write your circuit. But that circuit itself can't be implemented on the hardware. For each of these IBM machines, they have a basis set of gates that they can apply to these superconducting qubits. And so the step you have to go through is to translate these gates that into gates that can actually be applied to the machine. But there's actually several stages, and it goes through here talking about the 6 stages. And let's see. So like the first stage of transpilation is that it converts any single and 2 qubit, or let's see, it involves, let's see, converting the circuit to all single and 2 qubit gates. So if you can write gates that involve more than 2 qubits. And this first step, if you had any 3 qubit gates, say, this first initialization step would bring that down to to an equivalent single and 2 qubit gate version. And then the layout step maps these virtual qubits in the circuit, say you have 0 and 1, to actual physical qubits on the back end. So the IBM quantum chip, say it has 127 qubits, and your circuit uses 2 qubits. So you have to pick out 2 qubits out of 127 to actually run the program on. And so that would involve a mapping, excuse me, there. And let's see. And so then when you have that, like the C0 gate here comes after the H gate, it's applied to 2 qubits that are right next to each other. And so if you have, say, this 127 qubit chip, and say you want to, say your that layout stage decided that you're going to use qubit 1 and qubit 127, and those don't, because they're the highest quality qubits on the machine, but those qubits aren't next to each other, then this routing part would involve inserting swap gates in order to be able to perform a gate which requires that 2 qubits be next to each other. Okay, and so the translation stage, this translates the gates into the circuit's target back in its base, its sets. So like I said, like here we use the H, C naught, C naughts, but this back end basis has has gates here. You can see that um, that we did not write. There's a rotation Z gate, a square knot X gate, this kind of thing. This we did not put in our circuit, but the transpiler converts our circuit to these for us. And then optimization, that's a pass that can be run to reduce the depth of your circuit. And scheduling, yeah, okay, there could be hardware aware scheduling passes. So, the bigger picture is you write this circuit here that has 3 gates in it, and you start the transpilation of that circuit before it actually gets run on the computer, and it involves 6 stages, and this notebook helps you see what those are and walks you through them. Gives you more detail, a lot of links to more information. Okay. Okay, so I think it's a very interesting, good start to Qiskit, very doable set of exercises. And with the graded ones in there, you know, that's fun because it helps you check what you're doing and you get feedback. Let's see, I think it was maybe notebook 2 that one of the steps of the grader, I was getting an error, so I put in a question with IBM on that. So it's possible they might need to update their grader on that. So if you do get one error near the end of notebook 2, I'd say don't worry about it. Go on to the next exercise and just run it as assume kind of without thinking that you've done any errors, and it will probably work for you. Uh, okay. Later, I'm going to upload these scavenger hunts, and I'm going to focus it on quantum computing applications, quantum computing fundamentals, and quantum computing ecosystem in this area, and business challenges. Again, I'll upload something there later. Let me just go through these tabs of applications, fundamentals, and ecosystem. For the applications, I've started that. So all 3 of these pages relate to the scavenger hunts. And what I'm trying to do, you can start looking at them for ideas about learning more about quantum computing in these areas. And what I'm trying to do here is highlight specifically partners in the Northwest Quantum Nexus. But in addition to those, I have a few others that are this is the quantum computing world is certainly global, and I have I have different companies listed on here in terms of the research that they've done. And so I think that's a really neat aspect of quantum computing, is to see like there's a lot of interesting stuff going on in a lot of places: Australia, Paris, Toronto. Let's see, I think I put links to a lecture in Germany. Um, and so I shouldn't maybe list the names, because I could keep going and going. So I don't mean to leave anyone out as I say that, but I think it's pretty neat looking at feeling the global community, and certainly Qiskit's all these challenges events that they hold. You get a good feel for that as well. People entering from countries all over the world: India, Colombia, Africa, Turkey, everywhere. Um, so let's see, I'll just scroll down. with the scavenger hunts, I'll give people a chance to do some exercise related to these different areas. But I have a lot of links in here already if you just want to explore. Fundamentals, the focus I have for fundamentals are hardware. There are a lot of different approaches to qubits right now, and we have few qubits at the moment. We have some error mitigation, error suppression, and research into error correction. And as it comes closer, there's a choice that can be made about do you want to try to run these early days code on error suppressed, error mitigated circuits, or do you want to run it which have maybe more qubits but higher error, or do you want to run it on an error corrected circuit which has a fewer number of qubits? And I'm going to try to put an exercise that there's a Medium article out there that addresses that, and try to put that into an exercise. If you're interested in what kind of quantum software is out there other than just Qiskit, I have this link to quantum programming on Wikipedia, and I'll click on that and you can see list quantum instruction sets, open chasm. This is underneath Qiskit. Quantum software developer kits. Google has Circ. Classique is interesting because they're trying to work at a higher level than these circuits that we just talked about and work more on a algorithm level. I might try to work in a Classique exercise for the scavenger hunt. Penny Lane comes out of Xanadu, which is a very interesting company working on photonic quantum computers. The IBM quantum computers involve superconducting qubits, but Xanadu's working on a photonic quantum computer where the qubits are photons, and they move really fast, those photons, and so they're handled differently. Let's see, we see Qiskit. Ticket is programming environment that Honeywell's Quantinuum and Cambridge Quantum Computing developed. And then we have a section here. So these were all under SDKs with access to quantum processors. But then you can see we have another section called quantum programming languages. And you see Q# on here, and that's what Microsoft is working on. So, yeah. Anyway, so just wanted you to just be able to get a bigger picture than just Qiskit and writing these little circuits, because it's not, eventually it's just to solve problems that many qubits are going to be required, not one or two or five, or these are just like toy exercises that you're working on with these notebooks. So if you start looking at these bigger pictures, you get a better idea about how to use the computers in the future. Let's see, I have a little bit, yeah, so I have some information here on quantum algorithms. And then finally, the challenges of building quantum computers to compute useful applications. Right now, there are no commercially useful applications being computed via quantum computers. Okay. Then quantum ecosystem. Just point out, like I said, I'm trying to highlight the Northwest Quantum Nexus here. Also, there's a kind of a interest in creating more startups in this area in quantum computing. Can get a check on the funding. How does it compare, say, here in the Northwest versus other parts of the country and the world? YouTube has a ton of resources. Qiskit has a very useful channel. There are a lot of academic lectures on YouTube. I list those here: Scott Aronson, John Preskill, Ronald de Wolf in the Netherlands, Professor Paulsberg down at UCLA, and then also conferences. A lot of these Q2B conferences are hosted by a company called QCware down in the Bay Area, and they hold conferences in California, upcoming in December, and then they also have one in Paris in the spring, and they had Tokyo in the end of the summer. And after the conference, they put all the recordings on YouTube, and that's a really valuable resource. Quantum information processing is kind of a theoretical conference related to quantum computing, and you can also find some recordings of theirs on YouTube. Okay, finally, what I will do is show you this resources tab. Okay, so I will click on this first one. This is a page that IBM provided for the Fall Fest. And let's see, so they have how to install Qiskit, Qiskit documentation, and then beginner information, intermediate links, to more information, whether you're on the beginner, intermediate, or advanced levels. So, I call it the CHSH inequality. I put it in my advanced category. They put it here just in the intermediate. So, I was just trying to separate something out into the advanced, but mostly the focus, IBM's idea is that the focus of this Fall Fest is for beginning and intermediate stages, and then their other events would be a little bit higher level. Okay, let's see. Some more YouTube, some books. This IBM has this book called The Quantum Decade, which I have a physical version of the book that they sent to me as I am an official Qiskit advocate, and they gave us all a copy of this hard copy of this book, but you can get it for free. Download it from this link. Nielsen and Chuang, they have this book that's considered kind of the standard, that was written quite a few years ago now. And then Robert Hunt at Google has written a book about quantum computing for programmers. And I put it on here because I was looking up a topic called the swap test. And I found his book I found the explanation that he wrote in there. He's like writes the math out into each of the individual steps that you go through in understanding that. And I thought his description of that was very good. So I wanted to put it up here. And then Olivier Ezrati, he's in Paris, and he has this Understanding Quantum Technologies book online. It's really thick, it's really big, it's very comprehensive, it's really nice. You can get it for free in digital form. He also sells it in pieces, volume 1, volume 2. I'm not sure if there's a volume 3. Just dividing it up into chunks so you can buy the physical parts on Amazon if you want. And then I found this new one, David Ryan. He's in the Seattle area, and he has a pocket guide to quantum algorithms that I saw. He's on Reddit, kind of active on Reddit, and he was telling people that if you contact him and give him feedback, well, he'll give you a free version of this a digital version of this for free, and you can give him feedback before they come out with the print version. Or you can buy it, the digital version as it is, from Amazon Kindle. Anyway, I just wanted to add that. Okay, so I think that covers it. For the to-do, I just give some instructions. You can join the Meetup Discord, and down on the schedule, I have a link to the Discord, and we can all interact there if you like. You can create a DoraHacks account, which you can see here. This is DoraHacks. You can create an account and then register for this hackathon. You can see right now we have 4. I clicked on the hackers tab. Oh, 7. We have yeah, okay, you've already done that. Good. So yeah, so anyone who hasn't done that, you can register there and you'll show up on the hackers page, and then you work on those notebooks, as I mentioned, and later keep an eye out for the scavenger hunts and the business challenges. And then we'll close everything up by November 25th, and you can submit a bildle if you want to be considered for a certificate, which the bar is not super high on receiving those certificates. So don't worry about that. And I'm leaving quite a bit of time here for the whole fall festival. I'm using up the entire window that IBM has made available. Let's see, the submission guide will tell you about submitting a bildle. So they make it really simple to do that. Okay, so I think that's it, and I think that's I think it's a great way for you to get started if you have never used Qiskit before. And if you have, I think it depends. You know, if you've gone through these other challenges this year, then you may feel like you know all this material and you may not want to focus on the Qiskit challenges, but you can wait and see about the scavenger hunts or possibly the business challenges. And also you can just, if you're in the Seattle area, you consider joining up with us in person on October 10th at the Peter Shore lecture or on November 7th at the Microsoft Reactor. And I hope to see you all there.